Good afternoon, everybody. Welcome to Wednesday afternoon of Chem 170 with your host, me, Dr. White. And if you've heard the weather report, they're talking this Friday, lots of snow. So get prepared. I don't know, I've seen it anywhere from 2 to 10 inches, depending where you are in the Chicagoland area. So make sure you got gas for your snow blower, your shovel's ready, and hopefully you don't have to go anywhere. All right, let's get started. All right, if you noticed this morning, I sent out an email, put an announcement on D2L, which let's get to that. And you'll see here now on your screen, let me check, I can do that now. Used to be you couldn't, I'd have to ask thumbs up people, but you should see on your screen the announcement for test number 2 information. All right, next Wednesday, the 8th, I will be giving test number 2 online. And you'll be able to download, just like test number 1, a password protected PDF file for test number 2 from the assignment area D2L sometime next Tuesday afternoon on the 7th. On the 8th, around next Wednesday, around 4 p.m. after class, I will send out an email with the password for the password protected test number 2 PDF file. You'll have until Thursday, 4 p.m., 24 whole hours, to finish test number 2, upload your test number 2 answers to the assignment area D2L. Now, most of my tests, if we were face-to-face, take about, like all of them except the final, take about 40, 45 minutes to finish the actual test. Take as much time. I'm not going to be standing there with a watch, hand it in. I could, and I've had students say, how come you didn't finish it? Well, I ran out of time. I finally realized, take as much time as you need. Now, test number 2 has 9 pages, 10 problems. Some of the problems are multiple part. There will never be a multiple choice question on any test or the final in Chem 170. It will cover alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones, which I'll finish up today. Here's the point breakdown for test number 2. General knowledge, 11 points. Nomenclature, 34. And reactions, 60. It adds up to 105, so there's 5 bonus points. You pick which 5 are the bonus points. This test is all my tests, will not be an open notes test. I have put things in the test so I can know if students do that, and I'll do what's in my syllabus. That's called cheating. Please don't. I just want to write myself a note, not to forget to do something. All right. Now, next Monday, I will do my world famous review for the next test, test number 2. And also, we'll finish today. On next Monday, I will go through the aldehydes and ketones problem set. I highly urge you to do them. We'll have our regular Zoom meeting with the lab and other material. And then at the end of that, I'll send it out, the password protected file. Now, with all my tests and the final 2, every question I have on that test, the concept behind that question, I've covered at least twice, usually a lot more times in our Zoom meeting. Don't forget, anything on the lab will never be on one of my tests or the final. I keep them separate. And what else? Oh, the best way to study for test number 2 is 1, do the practice problems. If you can do the practice problems correctly, you're in good shape. Also, you can come back and look at these videos or study your notes. All right, any questions about test number 2, which will be next Wednesday through Thursday? Got my speaker on. When I first started doing Zoom, when the pandemic hit and we switched to Zoom, I forget to turn on my amplified speakers. And somebody'd say something, says, "Is there something wrong with your mic?" And the other said, "No, do you have your speakers on?" Oops. All right, since there are no questions, if you do, come to my office hour tonight from 6 to 7:15 or email me. Because remember, my class, there's no such thing as a dumb question. Now, one thing I want to discuss with you on a personal matter, and that's my office hours. I haven't had anybody show up. Now, that could mean you people are doing well and don't have any questions, or I picked a time where none of you are available. So if you would like a different time on Tuesday and Thursday, Wednesday, Thursday and Friday, I'm busy, so I don't have time to do office hour. But on Tuesday and Thursday, anytime after our class, because in the morning I teach at the other school on Zoom, let me know and I'll switch it. If a couple people or anybody wants to switch, I can do that. See how powerful Dr. White is? Nah. Anyways, you get the message. All right. First of all, oh, I forgot to ask. Did anybody happen to think of ethanol and alcohol when you drove by a gas station? Because gasoline in our area contains up to 10% ethanol and alcohol. Did you do that? Did anybody happen to pick up a bottle of rubbing alcohol and see it contains anywhere from 70 to 90%, depending on what type you got, of isopropyl alcohol, which is an alcohol? Or did you happen to pick up a bottle of nail polish remover and see it contains acetone? And acetone is a ketone. Oh, let's do one more. Anybody happen to pick up a bottle of hard spirits? You don't have to drink, but happen to look at it, like the good stuff vodka, and see it contains ethanol and alcohol? Remember, organic chemistry is all around you, and it wouldn't hurt for you to think about it outside my class. All right. You know something? I'm looking out at all of you. I have X-ray eyes for those who don't have a webcam or telescopic, not X-ray. And I think you need a pick-me-up. So let's play that fun game. What fun game? Let me get my tablet ready. Let's play that fun game. Let me get it right. Let's play that fun game. Circle and name the functional groups in the following. Again, you're playing that fun game. I'm not asking for the IUPAC name. I'm asking for circle and name the functional group in the following. Oh, I'm gonna give you a lot of fun today. So have some fun. Remember, this is that fun game. Circle and name the functional group or groups in the following 2 points each. Have fun. And don't forget, there's a lab due today, the one we did last week, which if my memory serves me right, I hope it does, was the electrophilic aromatic substitution laboratory, which was the nitration of bromobenzene. Today we'll have fun with alcohols. Oh, I hope Dr. Sam didn't hear me say that. We're not going to be drinking anything. We're just going to do the lab with alcohols. And take your time. This one takes a little time. I gave you 5 of them. And look for what's different. If you finish early, please be patient. I'm trying to give everybody time to finish. And when you're done, don't forget to vote. And just answer yes if you're done, please. All right, let's get going. And the fun game is circle and name the functional group. 2 points each. How do you do that? You look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. If we look at an oxygen with a hydrogen on a carbon, this part you don't have to do, but I will. And what's ROH? This, it's an alcohol. Now, if you circle the next carbon or two, don't worry. Let's look at B. Look for what's different. Oxygen. Carbons here and here. You don't have to do this, but I will. What is this? It's an ether. Next, let's look at C. What's different? What's not carbon? What's not hydrogen? An oxygen double bond to a carbon. Carbons here and here. And what is that? It's a ketone. And by the way, ketone is not spelled with a Y in there. Hint, but I don't take off for spelling unless you put ether instead of ketone. That's not a spelling error. All right, let's continue in D. Oh, look, there's an oxygen with a hydrogen and a carbon. What is this? It's an alcohol. Oh, wait, we're not done. I made a mistake here. That should be a H. I apologize. I was thinking of the next chapter. I don't know why that. Hold on. Bad, Dr. White. And what is this? Carbonyl, hydrogen, carbonyl is carbon, double bond oxygen, R group. This is an aldehyde. It's the first time I ever did that. I don't know, must be, it's not Friday the 13th, even though my Friday the 13th have been lucky. All right, let's do E. We look for what's different, what's not carbon, what's not hydrogen. An oxygen with carbons here and here. And that's an ether. Now, you don't have to put down the ROR prime, but you have to circle the right stuff and put down the word ether. Are we done? Oh no, another carbon. Oxygen, I mean, double bond to carbon with carbons here and here. What's this? A ketone. And if you didn't circle all the carbons, that's okay. Are we done? No, an oxygen here with carbons here and here, a second ether. Are we done? No, another oxygen. And this has carbonyl, carbon double bond oxygen, hydrogens, and right here, I have carbons. This is an aldehyde. Boy, I threw in everything but the kitchen sink on E. That's an aldehyde. And that's how you play the fun game, circle and name the functional groups, 2 points each. Now, on a practical matter, if you can't identify a functional group in a molecule, how can you name it? You can't. If you can't identify a functional group in a molecule, how do you know how it reacts? You can't. So even though it's a fun game, circle and name the functional group, 2 points each, is a very important skill. When I look at a molecule, organic molecule, the first thing I do is scan it to look for all the functional groups. In other words, I look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Gets my attention really quick. And that's where the fun is. All right, any questions about that fun game? Circle and name the functional group, 2 points each. All right, on Monday, I started talking about the reagent lithium aluminum hydride, and this is called a hydride reduction or lithium aluminum hydride reduction. And a reduction is where you convert an aldehyde or ketone with lithium aluminum hydride, first step, acid and water, second step, to an alcohol. And remember, first step is lithium aluminum hydride. Second step, acid, H plus. This means acid catalyst. And that could be sulfuric acid or other acids I'm not going to talk about. And water. I think everybody knows H2O is water. I hope so. And keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it, R prime or hydrogen, and our double prime is still there, comes along for the ride. But the carbon oxygen double bond, the pi bond is broken, and each atom of the carbonyl gets a hydrogen. You make an alcohol. And since I already gave you an example on Monday, I'm going to let you have some fun right now. Give the organic product or products for the following reaction, 3 points each. Your turn. And when you're done, don't forget to vote. All right, let's do this. What do we have that's different? Oxygen, double bond to carbon, a hydrogen here and here, that's an aldehyde, but it could have been a ketone. If R prime is H, it's an aldehyde, R prime is carbon, it's a ketone. React it with lithium aluminum hydride. I've worked with this stuff, interesting stuff. And second step, acid and water. Keep your eye on this carbonyl. What's attached to that carbon stays attached. And you break the pi bond here, and each atom gets a hydrogen. So here's my R group, or another way of thinking is you break carbon-carbon single bonds. No. So I have 1, 2, 3, 4 across my R group. And this carbon right here, which came from this carbon right here, becomes an alcohol. Now you can write it this way. And there's already a hydrogen. There are 4 bonds to carbon. Or you could have written it this way. Either way would be correct. These two are identical, one butanol. And that's lithium aluminum hydride. Oh, let's do another one. On test 2, I have 3 or 4 synthesis problems. And the question is, what do you start with and react with lithium aluminum hydride, second step acid and water to make that product? Well, it's like some of you are really getting this good. Makes Dr. White very proud of you. And you should be proud of yourself. And this is the fun part of organic chemistry synthesis. How do you synthesize something? Synthesize means to make, which is my training. I'm a carbonyl synthetic organic chemist. All right, let's do this. First of all, you look at the product. What's different? What's not what's not hydrogen? Oxygen with a hydrogen on this carbon. And it's an alcohol. And what do you react with lithium aluminum hydride, second step acid, catalyst, and water to make this alcohol? If R prime is hydrogen, that's a primary or secondary alcohol, which I'll never ask on a test. And the answer is a ketone or aldehyde. And remember, the carbon with the hydroxyl group will be the carbon with the carbonyl, carbon double bond to oxygen. So what's our R prime and our double prime? Well, they're connected together in the ring. And here's this carbon, which is that carbon. So since you don't break carbon-carbon single bonds, I'm going to start with this ring. And also we'll have the ethyl group. Which carbon has the hydroxyl group, this carbon, which will be this carbon, meaning it's a ketone. And that's how you do it. Oops, wrong chapter, wrong thing. All right, everybody see oxidation of carbonyl compounds on your screen? I'm cutting that out. That will not be on test 2, it'll be on test 3. So this will not be on test 2. I should have taken it out, I forgot. All right, now the next part, the next couple of slides are going to turn the switch, click off. Will this be on test? No, but this is background information for a reaction that will be on the test number 2. And I have to warn you, this next area I'm going to talk about, that's the area I did my PhD thesis on, part, not the exact area we're going to talk about. And I'm a world authority in what's called enolate anions. And if it looks like I'm having way too much fun, I am. So let's talk about enol keto tautomerism. Let me make sure you can see this. You can. Now, what is this? An enol keto tautomerism. A tautomerism is where you move electrons in one atom to make something else that's in equilibrium with each other. And see board, I'll write it right here, and you don't have to write this down. And let's just do it for an aldehyde. Well, it could be a ketone too. If R prime is hydrogen, it's an aldehyde. If it's carbons, it's a ketone. Now, this enol keto tautomerism, I'm going to move a hydrogen from there to the oxygen of the carbonyl. There'll be too many bonds there, so this will move here. And what you get, oops, unwhoops. Is this, and they're in equilibrium, they exist together. Now, this is called the keto form, and this will not be on a test because it's a ketone or it could have been an aldehyde. Why they didn't call it the aldol form, I don't know. Somebody did this well before Dr. White was born. Now, this is called the enol form. En from ENE double bond, OL from alcohol, enol. Now I'm getting really happy. All right, let's move on. Now, it turns out the alpha hydrogen, and let's write a ketone or aldehyde this way. I'll never ask on a test, but you should know the hydrogens on the carbon attached to the carbonyl, this one is called the alpha carbon. Dr. White loves alpha carbons. And let's talk about the acidity of the alpha hydrogen to form the enolate anion. Now, the hydrogen, alpha hydrogen, hydrogen on the alpha carbon in carbonyl compound is more acidic, meaning you can take a base and pull it off. It's a proton donor. Remember, switch is still off. This won't be on test, but it's good background. Then a hydrogen, like on an alkane or an alcohol. This is due to resonance stability of the enolate anion. Now I'm really going to have some fun. If you pull a proton H plus off this carbon, it will have a negative charge. And this is called the enolate anion. This won't be on a test, but Dr. White loves enolate anions because that's what I did my PhD thesis on. Actually, very specialized that most organic chemists wouldn't even understand. And that's kinetically favored cross-conjugated enolate anions. And that's part of my PhD thesis. But anyways, this exists not as an equilibrium, but a resonance form. You move the electrons here and the electrons here. And this is another way of writing the enolate anion. And the enolate anion I worked with, old memory time, is a specialized type. It's called a cross-conjugated enolate anion. And I did reactions with that, which was my PhD thesis. But anyways, the alpha carbon has hydrogens that can lose, by adding a base, a proton to form the enolate anion. And now switches, wrong hand, click, switches on, full blast. Let's talk about the aldol condensation. And the aldol condensation use enolate anions on the alpha carbon as a nucleophile. Now, here's the reaction, one way to write it. And I'm going to make it easy. I'm just going to do aldehydes. You can do it with ketones too, which is what I did, but this makes it easier for you. Don't tell anybody I'm being nice. Shh. But anyways, normally organic chemists wouldn't write, they just write one aldehyde. I'm going to write two of the same. And usually have a solvent like ethanol or water, which I may or may not put down. For this class, I really haven't been talking about solvents. Well, let's look at a better way of writing it. Excuse me. Getting all choked up over this. Something very near and dear to my heart. Now, there are other bases, but for this class, I will use sodium hydroxide. We look at one of the aldehydes. I'll remove a hydrogen from there. I'll get an enolate anion, and that will attack the other carbonyl. And since you're going to be in a protic solution, water, ethanol, what happens is the first aldehyde makes a carbon-carbon single bond, which is why this is a great reaction, to the second aldehyde and opens it up to an alcohol. What's attached to it is still attached. And this is called an enol or aldol, because aldehyde, alcohol, OL. Now you can do it with ketones too, but that's a little more complex. We'll do a lab on that, but not now. All right, so the key is, all right, what just happened? I don't know, my machine locked up for a second. The alpha carbon, the hydrogens you can remove with base to form an enolate anion, and this carbon bonds to the carbonyl carbon of the second aldehyde, and you form that very special thing, a carbon-carbon single bond. And let's do this one. Now, the giveaway is my gift you see two of the same aldehyde in a reaction, that's my gift to you. Shh, don't tell anybody I'm being nice. In real life, an organic chemist my level would just write this, wouldn't even write a 2 in front of there, do this, and everybody knows the aldol condensation. Now, the alpha carbon has acidic protons. You form the enolate anion and attacks that. So I've taken off. Notice this has 2, this has 1, this carbon. Everything else stays the same. Then the arrow shows you it attacks and bonds. Did I tell you organic chemists are violent? We are. It attacks the other carbonyl to open it up to an alcohol. And what's on this carbon is still there, H, CH2, CH3. And this is a new molecule. Now, if you wanted to use general reaction, oops. Remember, the alpha carbon has acidic protons. The base removes 1. 2 minus 1 is 1. And you do that very special thing. You form a carbon-carbon single bond to the carbonyl of the other aldehyde, which opens up to an alcohol. And what was attached to it? That's another way of thinking of it. In our example, what was our methyl? And that's how you do the aldol condensation. Boy, am I happy. Brings back old memories, very old memories. All right, let's have you try one. Your turn to have fun. I should tell you, I will never give a synthesis problem with this reaction. I will never give a synthesis problem, give the starting materials. That's cruel and unusual punishment. And as of now, still, the Supreme Court has outlawed that cruel and unusual punishment to students. All right, I think everybody's done. And let's do it. What do we have here? What's different? My phone ringing. 3 more rings. Stop. Oh, it listens to me. All right, let's do it. What do we have that's different here? An aldehyde. And I'll write it this way because, look, it's the same aldehyde. And that's my gift to you. Shh, don't tell anybody. I'm reacting this with sodium hydroxide, and you usually have water, ethanol, but I won't. And that's because you form the aldol condensation. You pull hydrogen off the alpha carbon of one and attacks the carbonyl of the other. And what you get and here we can say R, because it's the alpha carbon that attacks this. R is ethyl. So if we look at attacking this carbon, the alpha carbon, I'll pull off one hydrogen, and now this attacks and bonds to that carbonyl, which opens up to an alcohol. And I have CH2, and my R group is 2 more carbons. If you look at this molecule, starting with a very simple aldehyde, I've made a very complex molecule in one step easily, and it's an high yield. And that's a good and fun thing to do. And that's the aldol condensation. I will never give you a synthesis for this reaction, but I will ask you to give the product or products on test 2 coming up next Wednesday. If I look at the clock, boy, time flies when you're having fun with enolate anions and Dr. White. It's time for a break. Let's take about a 5-minute break, and I can get up and stretch, and I'll come back and we'll continue. See you in 5. I'm back. Surprise. All right. Now, let's get back to aldehydes and ketones chapter. And we've just finished the aldehyde aldol condensation. If you scroll down, we're done with this chapter. Notice in the lower left-hand corner of your screen, you see I'm on page 28 of 28. We're done with the aldehydes and ketones chapter. Let me close that file because we don't need it anymore right now. We're done. I have covered everything that will be on test number 2. Remember, on Monday, I will go through the aldehydes and ketones problem set. I highly recommend you do it before I do. Also, on Monday, I will do my world famous review for the next test, test number 2. And we'll do other stuff too. So it's time to move on to a new chapter. This new chapter will not be on test 2, but it'll be on test 3. Oh, I think I better go to, that's better be on test 3. Oh, it's broken again. There you go. All right. So what's this new chapter? Well, in this new chapter, you'll learn about the first chemical reaction I ever did with my hands. When you're a fetus, I think, I'm not an expert in this, or when you're born, you know, your body's doing chemical reactions. Well, when I was about 5.5 or 6, my father, who loved chemistry, why did he become a chemist? He was a pharmacist, but he still loved chemistry. Great man. And I really still miss him. He's been gone a long time, but great man. And I'll teach you the first chemical reaction I did with my hands. Also, my father was a great cook. My mother was a very good cook. He was a better cook. And I cook, and I'm a really good cook. Did I tell you, if someone's a good organic chemist, they're a good cook? If they tell you they're a good organic chemist, but they can't cook, they're lying to you. One of those things isn't true. But anyways, I'll teach you my father's secret recipe, how to make the best spaghetti sauce. And we'll do a lot of other exciting things in this chapter. And what's this new chapter? Oh, I forgot one other thing. We'll cover something that smells really good. I mean, really good. So this new chapter, chapter 10, you're reading a book, you don't need to, but if you were, deals with carboxylic acids and their derivatives. A carboxylic acid, what's that? It's a new functional group, and it contains a carbonyl and a hydroxyl group attached to the same carbon, and that is called a carboxylic acid. Now, that's better. The general formula for a carboxylic acid is this. This is how my software did it. But in class, I'll generally write it this way. This is a carboxylic acid. And yes, I've worked with carboxylic acids in industry, chemical industry. So I know them quite well. And you can write it this way or this way, but in the classroom, I'll do it this way. On a test, I'll try and do it this way, but print it. Now, if you go on the internet, you might see a carboxylic acid written this way or this way. And if you think about it, if you look at the carbonyl carbon, it's got 2 oxygen, a hydrogen, which is how this came, and similar to this. Now, when we get into fats and oils, I'll use that, but I'll remind you that's another way of writing a carboxylic acid. All right. Well, let's talk about how do you name carboxylic acids? What's the IUPAC rules? And you know, I'm never going to ask you to repeat them, but I do ask you to know how to use them. So let's look at a carboxylic acid. First of all, how do you know this is a carboxylic acid? Well, you look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, should get your attention like that. And wait a second, we have a carbonyl, carbon double bond to oxygen, but it also has a hydroxyl group, OH, on it, and carbons. This, and that is a carboxylic acid. Now, how do you name these? You find the longest chain that contains the carbonyl carbon, and you name it as an alkane. You drop the E at the end of the alkane name, and you replace it with the letters OIC and the word acid. You find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name that as an alkane, drop the E, add the letters OIC and the word acid. You cannot have a carboxylic acid in a ring. Therefore, you need no number. Because the carbonyl carbon, that's shorthand for that, is always carbon number 1. So let's do this example. What's the longest chain? 1, 2, 3, 4, 5. That's pentane. Drop the E because it's a carboxylic acid. I add the letters OIC and the word acid, and that's pentanoic acid. All right, and when you have, remember, this is carbon number 1, but you don't have to put that there because everybody knows that, just like aldehydes, the carbonyl carbon is number 1. It rocks. And you name all alkyl groups the same way you've been named alkyl groups. And why don't you try this one for your fun and enjoyment on this Wednesday afternoon? Aren't you glad I'm not one of those instructors who say, hi, this is a carboxylic acid. I'm asleep already. I get fired up over this stuff because it's fun. Give the IUPAC name for the following 3 points each. I think everybody's done, so let's do it. How do you know how to name this? You look for what's different, what's not carbon, hydrogen. Ooh, oxygen here and here. You have a carbonyl, carbon double bond to oxygen. That same carbon has a hydroxyl group, OH, and it's got carbons. And this is a carboxylic acid. Oops, that C got out of place. And remember, find the longest chain with the carbonyl carbon in it, name it as an alkane, drop the E, add the letters OIC and the word acid. No numbers needed, but the carbonyl carbon is number 1. So how many carbons in the longest chain with that? 1, 2, 3, or 1, 2, 3, 4. I hope you all agree, is the math hard? Near 4 is greater than 3. 4 is butane. So I'm going to drop the E, add OIC in the word acid, butanoic acid. Now, as soon as I say that, this is all spoken for. Oh, look, we got something left over. It's your old friend, the methyl group. And what carbon is it on? This is 1, that's 2. So this is 2-methyl butanoic acid. Oh, let's do another one. And the question is, give the IUPAC name for the following molecule. And there you go. What's the IUPAC name for that molecule? Oh, it's a pretty one too. And please be patient. I try and give everybody time to finish. All right, looks like everybody's finished, so let's do this. First of all, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon double bond. Ooh, oxygen here and here, carbonyl, hydroxyl group to that carbonyl carbon, R. This is a carboxylic acid. And you find the longest chain that has the carbonyl carbon, carbon double bond to oxygen, name it as an alkane, drop the E, add OIC, and the word acid. Give myself some more room space there. And the word acid. Remember, the carbonyl carbon is always number one. So if we look up here at the structure, 1, 2, 3, 4, 5. That's one chain. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is 8. Are you seeing red dots before you? Let me get rid of those. All right, so longest chain is 8. Octane. It's a carboxylic acid. Drop the E, add OIC in the word acid. Octanoic acid. Aren't you glad I don't give pronunciation quizzes? Nah, I don't. Now, as soon as I say that, this is all spoken for. Oh, here we have an ethyl group. Here an isopropyl. The carbonyl carbon is 1, 2, 3, 4, 5. So I have 2 ethyl. What am I saying? 2 ethyl. Thinking of something else, which I'll teach you later on. That's the 2 ethyl. 5 ethyl, 3 isopropyl octanoic acid. Now, since I'm not asking you to follow the alphabet rule, if you had put down 3 isopropyl 5 ethyl octanoic acid, that would be correct, even though don't tell the IUPAC police because they'll come and arrest me. No, there's no IUPAC police. But that's how you do it. Find the longest chain with the carbonyl carbon of the carboxylic acid, name it as an alkane, drop the E, add the letters OIC and acid. Remember, the carbonyl carbon is always number 1. And you do the alkyl groups like we've done. Now, there are 2 types of nomenclature questions I have on my test. One is, here's the structure, give the IUPAC name, and the other is draw the structure for the following. Now, one thing I should point out, I always draw my carbonyls for carboxylic acids and aldehydes on the right. You can do it on the left too. I just don't. All right, how do you determine what do you draw from this name? How do you decode it? You start from the right and move left. OIC acid. That's a carboxylic acid. And if that were an E hexane, 6 carbons. And the N carbon of those 6 will have my carboxylic acid. And then I know there are 4 bonds to carbon and I'm done. And if there was something else like this, two-methyl propanoic acid, we'd start this way, OIC in the word acid, carboxylic acid. That word E, propane, 3 carbons, but it's a carboxylic acid, so the end carbon, now you could have done it on this side, but I don't. And then as we keep on going, oh, a methyl CH3, and it's on carbon 2. This is 1, always 2, and there are 4 bonds to carbon, and I put it in my hydrogen, 2-methyl propanoic acid. I better let you have some fun too. And why don't you draw the structure for heptanoic acid? 3 points each. All right, time for me to work. How do you decode this? You start from the right, move left. OIC in the word acid, it's a carboxylic acid. And if this were an E instead of OIC, heptane, that's 7 carbons. And one of the N carbon, either N, but I do the right, is the carboxylic acid functional group. And there are 4 bonds to carbon. And that's how you do it. Let's see, 1, 2, 3, 4, 5, 6, 7. I did it right. Oh, let's do one more. And why don't you draw the structure, 3 points each, draw the structure for 3-T-butyl 5-methyl nonoic acid. Say that 5 times quick, 5 times quickly. You don't have to. All right, I think everybody's done. My turn. How do you decode this? Know what to write, draw? You start from the right, move left. OIC acid, that's a carboxylic acid. If the OIC were an E, no name, 9 carbons. The N carbon, I always do it on the right. You can do the other side, but I won't, is my carboxylic acid. And this is carbon 1. On carbon 3, I have a T-butyl group. 4, 5, on carbon 5, I have a methyl group. And now I got to put in hydrogens. Remember, there are 4 bonds to carbon. And that's the structure. 5, 3 T-butyl, 5 methyl, and this is 9 carbons. I counted right. Yep, 5 plus 4 is 9. I did. Yay, Dr. White. And that's how you do it. So that's how you do nomenclature of carboxylic acids, IUPAC nomenclature. And what I just went through is on this chart. And it looks like I got to do something. Hang in there. All right, now, carboxylic acids have been around for a long time, and there are a couple of common names I'd like you to know the structure for. I'll never ask for a common name. Here's the structure, give the common name, but I will ask, here's the structure, give the common, draw the structure. Now, carboxylic acids have this general structure. Now, it turns out you can have a carboxylic acid where R is H, and this is called formic acid. The IUPAC name, 1 carbon, methane, drop E, add OIC in the word acid, methanoic acid, nobody ever uses. This is formic acid. Now, how many of you have heard of the fire ants? Those are ants, and I think they're mainly on this deep south of the United States and Mexico and Latin America. And these are ants that mix a chemical water in their body, heat it up, and if they're attacked, spray it at their attacker. And the chemical they mix with water in their body is formic acid. And I don't know if you've ever heard what's called an acid burn. You get certain acids on your skin, I've never have, but unfortunately in one lab at the other school, I had a student do that. It burns, just like if you slapped hot metal on there. That I've done not intentionally, but touch something hot, it burned. And formic acid and water heated up is the defensive weapon fire ants use. Now, acetic acid has this structure when R is methyl. Nobody calls this by the IUPAC name ethanoic acid. Guess what? I would bet almost all of you have acetic acid in your house. where you live. No, I don't. I'd know if I had an organic molecule of acetic acid. Well, you do. If you take about 4% acetic acid and about 96% water, mix them together, you get a homogeneous solution. And you know what we call that? Vinegar. The next time you look at a bottle of vinegar, it's a dilute solution of acetic acid water. Now, some of the specialty vinegars have other minor components that give it its nice taste. If you see on your screen, we have some rice wine vinegars, and my favorite is the Marucan regular rice wine vinegar. If you come over to my house, you'd find in my kitchen, I have a bottle of that. I also have a bottle of apple cider vinegar and regular plain vinegar, which is also called white vinegar, even though it's clear, not white, and it's not named after me, Dr. White. But this is really good vinegar for a lot of things. And you can buy it in many stores. They even sell, they even sell it in Jewel. Now you know it's mainstream. About 10, 15 years ago, you wouldn't find this in Jewel, but you could go to an Asian store and get it easily. Now, the last common name, but listen carefully, this has also become an IUPAC name, is benzoic acid. And benzoic acid is both the common name and the IUPAC name, where the R group is a benzene ring, and that's benzoic acid. So on a test, if I ask, give the IUPAC name for this molecule, it's benzoic acid, and you should also know how to draw the structure of benzoic acid. I'll teach you later, this chapter, that a molecule made from benzoic acid is the preservative in pop. Remember, Dr. White is from the mid-Chicagoland area, and the stuff in bottles and cans that's carbonated, non-alcoholic, we call pop, not soda. Now, switches off for this slide. We'll learn later you can have very long chain carboxylic acids, and I forgot to write the term carboxylic acids. If you work in the industry, you just call them acids. And when the R group carbons and this carbon add up to 12, it has the common name lauric acid. When it has the common name, or 16 carbons, is palmitic, 18 stearic, 18 with one double bond, oleic. And when we get into fats and oils, we'll talk about these long chain carboxylic acids. Switch is totally off. Click for this slide. Do I have time? I do. All right, switch is off for this slide. Now, if you've ever worked out too hard, you get that burning feeling in your muscles. Yes, I still work out with weights. That burn is caused by lactic acid. Remember, it's totally off for this slide. And lactic acid, that's the common name, has on the alpha carbon alcohol as the 3 carbon. And this is lactic acid. Now, I'm going to talk about something that's just organic chemistry, but don't get upset morally. I like to go into stores or see products and figure out how do they do that. And years ago, a company called KY Jelly, or KY Company, that makes a personal lubricant for certain personal activities. Look it up if you're not sure, KY lubricant. And they came out with one called heating gel. And how did they do that? Well, when I read the label, at the very end, they had lactic acid. And when you put it on certain parts of your body for personal activities, it heated it up because you were getting a very, very tiny acid burn. They since changed that to an alcohol, and that does by hydrolysis. Now, another carboxylic acid actually has three of them, 1, 2, 3, and an alcohol is citric acid. Again, switches off, but citric acid is the chemical in lemon and limes that make it sour. If you've ever bitten into a lime or lemon, especially a lemon, ooh, is that sour? Well, this is the molecule that makes it sour. And how that does it, I have no idea. I'm an organic chemist. I know the molecule. Citric acid is a white solid at room temperature. And if you've been following over the last decade or so in children's candy, they've been somehow like this generation that's buying the candy to children, sour and super sour candy. I don't, but they do. They sell a lot of it. And how do they make it super sour? They put in a lot of citric acid. No, you can make citric acid synthetically in a plant, chemical plant for food chemicals. And this would be a good time to stop. Don't run away yet. The carboxylic acids, remember, vinegar is acetic acid and water, but that's test number 3 stuff. And let's talk about today's lab. It's lab time. And let me open it up first. All right, today's lab is the alcohol lab. Now, if we were face-to-face, I'd remind you it's flammable. We don't have any Bunsen burners or matches in the lab, but I still remind you, and we'll have a waste bottle in the back and a hood for all the waste. Now, these labs I created to give you an experience with alcohols. Unfortunately, we're not face-to-face. You can't do this in your home, but we can still talk about it. Now, the first one is solubility of alcohol in water. Now, alcohols, because of the difference in electronegativity of the oxygen hydrogen, the oxygen is slightly negative. The slight delta, lowercase, means slightly. And the hydrogen is slightly positive. Now, let me remind you, in water, the same thing exists. This is called a dipole. And opposites attract. The slightly positive hydrogen is attracted to the oxygen there. And in another water molecule, this happens, and that makes it water soluble. Now, how many carbons can affect the solubility? Because a certain part, the hydrogen bonding is not enough to cause solubility. And that's what you're going to be testing for. Oh, I should mention, if you're in a bar and bartender gives you a mixed drink with water in it, you can say, you know, the alcohol in that drink is soluble because the hydrogen bonding between the water and the alcohol molecule. Bartenders don't be like taught chemistry, organic chemistry. But anyways, what you would do is in a small test tubes, you add enough deionized water, DI water, to fill about a third of the test tube. Next, you'd add 5 to 10 drops of the alcohol being tested. You'd mix it by hitting the side of the test tube, or what I put out when we were face to face, we got them a couple of years ago and they're nice, is a vibro mixer. You take the test tube, push down this rubber disc that's got a motor underneath, and it starts vibrating real quick, and it mixes the solution in the test tube. Then you make an observation, and you look, is it the same throughout, homogeneous or heterogeneous 2 layers? And then you repeat them for the other ones. Now, what you're trying to do is it's soluble or not. Now, notice I have here, please draw the structure for the alcohols in this table underneath their name. And you would test ethylene glycol, isopropyl alcohol, terbutyl alcohol is called 2-methyl-2-propanol, 2-hexanol, 1-oxanol. And you'd see if you're in the lab, you get this results, which you're not, so I give it to you. That's the first section. The second section deals with the odor of alcohols. I wanted students to get a feel for this is an alcohol. And the alcohol is being tested. Dr. Daly, who's the laboratory manager and also teaches 2-semester organic, great guy. Before he was hired, I'd have students rip pieces of paper towels, put some stuff on there. Remember, never stick a chemical under your nose. Smell it this way, smell it and identify it. And he had, when we started, he said, I came in the lab one time, we were doing this before to check everything, because he was now setting it up. I wasn't. It saved me a lot of time in my life. Really nice now. And he had a piece of paper towel cut. And you put some on there and you smell it. And over the years, here's what students say they smell like. So you don't have to do this. Now, the next section will be oxidation with potassium dichromate, and it's acidic to make it do quicker. And this is the same test used by the police, or same based on using this type of reaction, police use to determine the blood alcohol level. And let's take a look at this reaction. You have a primary alcohol and you react it with potassium dichromate solution. This has an orange-red depending on the concentration of the solution. It oxidizes the alcohol to an aldehyde. But when this is oxidized, this gets reduced and you get a chromium 3, which depending on the concentration is green, blue, or a blue-green color, which is quite different from red or orange. And the blue-green almost looks turquoise. No, I didn't bring my turquoise ring I got in Santa Fe long ago. So if you run this reaction and you get a color change to this, you know you have a primary alcohol. Well, guess what? Secondary alcohol, same thing. I guess I should have written it orange, red, doesn't matter. My sisters always say, you don't know your colors. Well, I know my red, green, and blue, but in other words, they're right. And this also will get oxidized. You should know that for test 2. And you get a ketone. And the same thing happens. You also, when you oxidize the alcohol, you make ketone, but you reduce the chromium here to chromium +3, and that has, depending on the concentration, green, blue, or blue-green color. Now, there's one last alcohol to consider. And this is a tertiary alcohol. And tertiary alcohols cannot be reduced. And if you put potassium dichromate solution in a tertiary alcohol, orange, red, you see no color change. Now, on a test, I don't give the reagent. I use bracket, close bracket for that and other oxidizing reagents of alcohols. But for this lab, primary alcohol will give you a blue-green color. Secondary alcohol will give you a blue-green color. Tertiary alcohol, no color change. And this helps identify one type of alcohol from the other. And this lab, you'll be using potassium dichromate. And here you add about 5-10 drops of the alcohol test tube, add about 10 drops of this percent acidic, aqueous acidic potassium dichromate solution. You mix it or use the vibro mixer, let it sit for a little while, minute or two, and then look at it and write down your observation. Now, we always wear eye protection and in the lab, but I still warn people about the acidic, but you're not going to be using it. If you were in the lab, this is what you would see for each one of these. And use this data to answer questions at the end of the lab. And finally, let's do the last part. This is cool, but I do this. And here, that's the reaction of an alcohol with sodium metal. And let's take a look at that reaction. It's something I didn't teach you in the lecture part of alcohols, but I like to teach you this. You take sodium, and I'll balance this because people get all upset if I don't for this one. I don't need you upset. You take an alcohol, any alcohol reacted with sodium metal, you'll make an alkoxide. Remember, we used that for Williamson ether synthesis. Plus, you'll make hydrogen gas. And I'm showing that the arrow here tells you the H2 hydrogen gas is given off as a gas or bubbles. Now, an alkoxide is a very strong base. In case you forgot, here's pH. pH below 7 is acidic. pH above 7 is basic. The closer to 14, the more acidic that molecule is. The closer to 0, the more, did I say it wrong? The more basic. When it's closer to 14, the more basic the molecule is. Closer to 0, the most acidic. And what I would do, because sodium metal can be very hazardous if you don't know what to do. Dr. White does. I've used it enough. So I do this as a demonstration. Now, how many of you are familiar with pH paper? And that's a paper that when you put a sample on there in an aqueous solution of water, you put the paper, you have a color scale. And you can all see on your screen the hydronium, I don't know how to pronounce it, hydrion pH paper, which we use. They've been around for decades. And you see the scale right here? You take the paper, put the chemical on there, water solution, changes color, you match it to that. And what I'll do is when we do this, I'll get a volunteer or two. I'll do the experiment, hold the pH paper by that scale, and have them determine what it is. And with this lab, what I would do is in a beaker, and this is what Dr. White would do, is I'd have some isopropanol in water. I measure the pH of that, and 7. Then I take some isopropyl alcohol, the alcohol, and put in sodium metal. And you get to see something really cool. You can find it on the internet if you want. And you'll see a lot of bubbles form. And then after it's all finished, I take with an eyedropper some of the solution that I created with the alcohol and sodium metal, put it in water, and measure the pH. And lo and behold, the pH is 13 now. So that means there's been a significant change in the pH. And let me remind you, when the pH increases, you're dealing with a base. When the pH decreases, you're dealing with an acid. And going from 7 to 13, well, I'll let you figure that out. I don't want to give it away. And if you notice, I have questions and observations. The important thing is, please use your experimental results, which I gave to you, to justify your answers. And these are the questions you need to do for handing this in. That's due next week. With that, I'm done. Hopefully you've had a nice week of organic chemistry with your host, me, Dr. White. If you need help, I'll have my office hour tonight. Remember, I'll send out an email. You can think of a better time in the afternoon or evening on Tuesdays. Let me know, and I'll see if I can reschedule my office hours so I can help you out. With that, don't forget, next Wednesday, test number 2, you got an email, and you also have an announcement in D2L. Next Monday, I'll go through the aldehydes and ketones practice problem set. Next Monday, I'll do my world famous review for the next test 2. And with that, I'll say, Gehen gesund. Remember, that means go in health in Yiddish. Gehen gesund. Goodbye. I stole that from Granny of the Beverly Hillbillies. Bye.